Hello, in this video we talk about charge and electricity. You might have experienced electricity in nature in many ways. We all have seen the lightning and the electric sparks as the light happen. We also might have experienced a shock from static electricity on a doorknob, for example. All of these coming are form of electricity and they come from the charge. So we define the charge as the physical characteristic of matter. When it is located in an electric field, it has a force, and the motion of this charge actually is causing the electric current to happen. So we know that like charges will repel each other, so we will have a repulsion force. So if you have two positive charges, they will repel each other. Same for two negative charges, they're gonna repel each other. On the other hand, opposite charges will attract each other. So these are the forces associated with those electric charges. The smallest charge that we have is the charge of an electron, which is 1.6 times 10 to the negative 19 coulomb, where coulomb is the unit that we measure the charge. Okay, so this is the structure of an atom that we have here. So within the nucleus we have the proton, which have a positive charge, and surrounding the nucleus we have the electrons, which we have negative charge. Both electrons and protons have the same charge as the electron. Okay, and we have a third element, which is the neutron, and this is neutral in a charge. Then we have two types of electricity. We have a static electricity and we have what we call a current, and this would be the main topic within this week. So let's start by static electricity. We say that we have static electricity when we have stationary charges. So remember your doorknob. This doorknob accumulates some charges on top of it, and then when you touch it, you get this electric shock. But those charges remain stationary; they don't move. And this situation happens usually when we have insulators. So insulators can accumulate a charge, but the charge cannot move into that insulator. On the other hand, we say that we have an electric current when the charge start to move from one point to another. And this happens when we have an electric conductor. So when we have a wire and you have a battery, then electricity will go through this wire. So for example, to light up your lamp. So this is one example of static charge. Both balloon and the wall are insulators. They accumulate electrons, and if you have two opposite charges, they're gonna attract each other, and that's why you can, if you rub the balloon, attach it to the wall, it will just stay there in effect to the electric forces between the two opposite charges. On the other hand, if those charges are start to move, we're gonna have an electric current. So we say that the electric current is the rate of flow of a charge at a point. So the current is the rate of a change of charge over time. So when we have an inductor, charges start to move there, we develop what we call an electric current. So here it's very important for us to differentiate between insulators and conductors. Charge can happen on both, so both can be charged. The main difference is whether the charge is gonna move, i.e. we're gonna have an electric current, or just the charge will be static there without any motion. So we say that for an insulator, the charge are not able to move at all from one point to another, so it's static in its place. And if you touch it, like the doorknob, you're gonna get a shock. Okay, so if I have an insulator and I try to charge this insulator, I'm gonna typically deposit or remove some charge from the surface of that insulator, but those charges, if you put them, they're gonna stay still there and they don't move across the surface of that insulator. On the other hand, if I have a conductor, when you charge that conductor, the charges can freely move from one point to another. So whenever you charge a point on the conductor, the charge will quickly spread over the entire conductor. So here I have this animation. If I have an insulator, you have a mean to charge it. So you add a charge, this charge just remain static at their place. If I try to charge somewhere else, we're gonna have the charges again, but those are static. They don't move, and therefore we don't have any current flowing through that insulator material. On the other hand, if I have a conductor, and as soon as I start to charge it, you can see the propagation of charge over the entire surface of the conductor, and this is the case when we conduct current from one point to another. So let's define the electric current rigorously. So we say that when we have a charged object and we have a conductor, then the electron will start to flow in this conducting path from a point with a higher potential to a point with a lower potential. So if we have a battery, the battery has two terminals. You connect the battery to an electric lamp. So this wire is a conductor. The battery will provide a potential power. So the current will go through the conductor, which is the wire. It will lit up our light bulb. Okay. Physically, the current is the rate of change of the charge. So as the charge moves per unit time, we're gonna observe a current. We can measure a current using a device called a meter, and the unit that describes the current is called ampere. So this is one example of a real circuit in which we have a current going through a wire. So here I mentioned the term circuit. So the circuit, an electric circuit, we say that the path through which an electron flow from one terminal to another terminal of a source is called a circuit. So here we have the battery. We're gonna have the charge move, so making a current that go through this terminal, go light up the light bulb, and go back to the other terminal. So here we completed a path. So this is what we call an electric circuit. An equivalent diagram for the circuit that we're going to study this course will have diagram for each of element. So this diagram here is for this battery. This is what we call a resistor, and this is a light emitting diode or a light bulb.